In recent years, the demand for disassembly is increasing. When a disassembly process, the damage that occurs is also decreased. In order to find the optimal solution, different steps and types of the evolution algorithm can be established via individual theoretic procedures and various virtual machines in cloud. Recently, the environment protection is the popular issue in trend item production. To minimize the material waste when recycling, to disassemble the objects with the on-demand defined process is the important issue. How to find a suitable, even optimal disassembling process with minimized time spending and total numbers of disassembling machines and workers are important for various objects. In order to find the optimal solution, they will propose evolution algorithms or genetic algorithms which based on the concept of survival of the fittest. This research proposed the cloud-based modular genetic algorithm with variable length multiple crossover medium for the optimal solution of the disassembly line network. Genetic algorithm is the evolution algorithm which follows the concept of survival of the fittest in nature, and there are several steps of the genetic algorithm including representation, internalization, selection, crossover, and mutation, and the procedures of the genetic algorithm are introduced as follows: survival and checking. There would be three possible disassembled partitions. The first one is remanufacturing for reconstructing new product, and the second one is recycling for reusing the product, and the third one is discarded. And three important factors are considered: workstations, disassembly cell, and disassembly line. To solve the disassembly line balancing problem, transformed and/or graph was proposed to represent the relationship or connection between different binding nodes. To represent the possible solution as the chromosome of genetic algorithm, the variable length chromosome is used. According to the total amount of the tasks corresponding to binding nodes, the same amount of operators will be assigned. Each task of the individual binding node with an assigned operator is combined as a working set. Based on the combined working set, the disassembly operation time of multiple working sets at workstation should subject to the workstation time limitation. The relationship between different working sets should also subject to the sequential limitation. To adapt the adaptive crossover medium for enhancing the performance of optimal solution searching should also be considered. Each task of the binding node represented as the gene of the chromosome should be assigned an operator. An operator can deal with single or multiple tasks at different workstations. Each task, individual workstation, and the corresponding assigned operator can be combined as the working information set called substring. Includes three genes: task number, assigned operator number, and the workstation number included in the chromosome. The first one is based on the uniform crossover medium, only the limited scope to the specific gene rather than multiple genes or a whole chromosome. In this research, the uniform crossover changes the number of tasks, or the operator number or the workstation number individually, and the second one is the point which is located between substrings included in the same chromosome is randomly selected. Since the point is randomly chosen, the total amount of exchanged substrings from different chromosomes would be also different. In this research, since there are three attributes such as task, operator, and workstation included in the chromosome, to suitable crossover these three attributes and the various length based on the crossover rate is needed. As follows picture. Since there is thus the probability difference between different crossover results, the crossover means related to T1, T2, T3, and T4, which are sequenced in the flowchart should be considered. In this research, the sequence of the Hilbert crossover is dynamically assigned. In other words, the sequence of the crossover corresponding to the task, operator, workstation, and length, noted as T1, T2, T3, and T4, could be dynamically changed. In other words, at least one crossover method would be executed. The task number, operator number, workstation number, and the total amount of the substrings or the length of the chromosome would be exchanged between parent chromosomes. Mutation. Since there are different methods for the crossover of chromosomes, suitable mutation like uniform mutation and the one-point mutation. Evaluation and fitness. Considering the disassembly line network tree structure, the relationship between different nodes or tasks can be defined. Cloud computing. To enhance the computing performance, large computing resource is needed. The open source cloud computing environment established on Ubuntu 14. Java 7 applications for parallel processing are implemented for various crossover methods and mutation methods. Suppose that the available processing time of each workstation is set as maximum 30. Therefore, if the summation of the processing time required by all the tasks assigned to one workstation is larger than 30, the task assignment is unavailable. In opposition, the extra assigned task which causes the total processing time be larger than 30 should be separated and assigned to an additional workstation. In this research, to suitably assign the tasks into the minimum workstations required is one of the optimal objects. One optimal total operation time could be corresponding to various operation sequences. Based on the proposed algorithm, the various operation sequences with optimal operation time can be found. The time cost for optimal solution searching is less than 10 seconds. According to the found available optimal solutions shown in the figure above, there are some sequential tree structures with different workstation assignment results. In other words, the task could be assigned to different workstations subject to the available processing time of individual workstation. In this scenario, the available processing time of workstation are set as 30. According to the found disassembly line optimal solutions, the final total processing time are all the same as 138 processing time units. There are total 6 workstations required for disassembly operation according to the operation time limitation of the workstation. In other words, the proposed algorithm could find the optimal Pareto from set solutions. In this verification, considering the workstation, the relationships between forward tasks, correct tasks, and workstation can be shown as follows. Suppose that there are 4 types of workstation corresponding to different tasks of disassembly line. The relationship between the correct tasks and the forward tasks are shown as follows. In addition, the operators are also the factor considered in this scenario. Different operators could do the corresponding disassembly tasks with different operation time through different workstations. Suppose that the workstations are available and usable for different operators, shown as the following tables. As follows. After about 800 generations, the proposed evolution can find the optimal solution corresponding to the scenario 1. Multiple sets related to the base relationship of the disassembly task, and scenario 2, the fewest workstations for the disassembly tasks. In this research, It can reduce the cost for establishing the evolution algorithm. Based on cloud environment, computing ability can be increased. The proposed cloud-based evolution algorithm can cause the optimal solution for users via distributed system and parallel processing architecture.